A very good morning, students. Today in oceanography, we'll be reading about the currents of Atlantic Ocean. Currents are a general movement of a mass of surface water in a fairly defined direction. In other words, an ocean current may be defined as any persistent, dominantly horizontal flow of the ocean water. After going through this lesson, we will be learning about the different currents of the Atlantic Ocean, the North Equatorial Current. Okay, to begin with the currents of the Atlantic Ocean, North Equatorial Current. As Defant puts it, the North as well as the South Equatorial Currents together form the backbone of the system are the currents present in the Atlantic Ocean. The North Equatorial Current is induced by the northeast trade winds which drive the tropical waters in a westerly direction. The North Equatorial Currents receive its water from the currents flowing from the coastal seas of the northwest Africa. The trade winds blowing from the African coast are offshore winds driving the coastal waters towards the west. This results in the upwelling of the cold and the dense water from the intermediate depth of the North Atlantic Ocean. Thus, the trade winds drive the cold water brought down by the Canary's current along the African west coast. The North Equatorial Current flows in the white belt with a latitudinal extent from 10° north to 30° north latitude. The motive force behind the current being the northeast trade winds. It affects the water up to a depth of 200 meters. However, to the south of 20° north latitude, the current flows at an average velocity of 15 to 17 nautical miles per day. In the western part of the ocean, the North Equatorial Current joins that part of the South Equatorial Current which flows towards the north after crossing the equator. This branch of the South Equatorial Current brings a different water mass. Thus, the mixing of the different water masses takes place in this particular region. The waters in the Caribbean Sea therefore are intermediate in character. After reaching a 60° west longitude, the North Equatorial Current bifurcates into two branches. One branch flows into the Caribbean Sea while the other flowing to the north of the West Indies joins the first branch near the 8° north latitude. The northern branch of the North Equatorial Current which flows along the northern side of the Great Antilles is known as the Antilles Current. It carries water which is similar to that of the Sagasu Sea. It may be stated that the first branch as referred to above flowing through the Caribbean Sea enters into the Gulf of Mexico and fills it with mixed water mass. Thus, the water level in the Gulf is raised. From the Gulf of Mexico, the water returns to the Atlantic Ocean through the Florida Strait. Thus, the Gulfstream comprises the following ocean currents which are Florida Current, the Gulfstream and the North Atlantic Drift or the North Atlantic Current. The equatorial countercurrent which flows between the North Equatorial and the South Equatorial Currents. There is an easterly moving equatorial countercurrent in the doldrums, the belt of the calm, which compensates to a certain extent the piling up of the water on the western side of the ocean. These countercurrents belong to the most conspicuous part of the ocean circulation. They form narrow bands which can almost always be traced to the entire width of the individual oceans and the zonal direction. They flow from the west to the east with an average velocity of 50 centimeter per second. In extreme cases, the velocity is of 150 centimeter per second by always average velocity of 50 centimeters per second. In extreme cases, the velocity is of 150 centimeters per second also may be attained. Such velocity is among the highest in the open oceans. In July, this countercurrent is more strongly developed than in January. In fact, the equatorial countercurrent is a downslope current between the two upsloping currents, that is the North Equatorial Current and the South Equatorial Current. This countercurrent is a very shallow current which is confined to the surface layer above the discontinuity. This countercurrent on the eastern side of the Atlantic merges into the Guinea Current which flows towards the east. This current flows at a high velocity along the African west coast. As stated above, during summer months this current is more strongly developed. In winter, on the contrary, it is in the form of a feeble current with no full development. In the northern winter, the countercurrent begins east of 24° west, whereas in the northern summer it starts east of 50° west and can be seen over the entire width of the Atlantic Ocean. The equatorial currents, which are warm in nature. The steady trade winds in the region constantly drift two streams of the water from the east to the west, starting from the coast of Africa. These two currents are called the North Equatorial Current and the South Equatorial Current. At the shoulder of the northeast, Brazil, the protruding landmass splits the South Equatorial Current into Fakan Current, which flows along the Guinea coast, and the Brazilian Current, which flows southward along the coast of Brazil. Between the two equatorial currents is the eastward flowing equatorial countercurrent. Since these currents are near the equator, all of them are warm currents. The North Atlantic Ocean, some of the prominent currents of this particular North Atlantic Ocean are given. First and foremost, the Fakan Current, which is warm in nature. In the North Atlantic Ocean, the Fakan Current is joined and reinforced by the North Equatorial Current. This current heads northwestwards as a large mass of equatorial water into the Caribbean Sea. This current is further split into two currents, the Florida Current and the Gulfstream. The Florida Current, which is again warm in nature. One part of the Fakan Current enters the Gulf of Mexico and emerges from the Florida Strait between Florida and Cuba. This is called the Florida Current. Gulfstream, warm. Another part of the Fakan Current heads northwards east of the Antilles as the Gulfstream. The Gulfstream is one of the strongest ocean currents. Next, the North Atlantic Drift, which is again warm in nature. The Gulfstream is deflected eastwards under the combined influence of the westerlies and the rotation of the earth. This reaches Europe as the North Atlantic Drift, since this drift carries warm equatorial water into the high latitudes of the Europe. It keeps the coast of North Sea frost free, facilitating suitable conditions for the ports. From the North Atlantic, the drift fans into three directions: eastwards to the Britain, northwards to the Arctic, and southwards along the Iberian coast as the Canary's Current. The Canary's Current, which is cold in nature, it flows southward along the coast of Europe and Africa to finally merge with the North Equatorial Current. Since it receives water from the polar regions, it is cold current. The flow of all the above currents completes a clockwise circulation in the North Atlantic Ocean. Apart from the clockwise circulation of the currents, there are other currents that flow into the North Atlantic Ocean from the Arctic region, like the Labrador Current and the EMRC Current, under the influence of the polar easterlies. Labrador Current, which is cold in nature. This current drifts southeastwards between the West Greenland and the Baffin Island of Canada. This current meets the warm Gulf Stream of the Newfoundland of Canada. Next, the EMRC Current, which is again cold current. It is also called as the East Greenland Current. It flows between Iceland and the Greenland and cools to the north and joins the North Atlantic Drift at the point of convergence. The Sagasu Sea, which is warm. It is an area in the middle of the North Atlantic Ocean formed by the currents flowing in the clockwise direction. A large amount of the flowing seaweed gathers in this region. It is the only sea on the earth without a coastline. It is bounded on by the west by the Gulfstream, north by the North Atlantic Current, east by the Canary Current, and south by the North Atlantic Equatorial Current. Grand Banks of the Newfoundland. We know that the regions of the confluence of the warm and the cold currents are regions conducive to the growth of the microorganisms and phytoplanktons. These regions form excellent breeding grounds for the marine organisms like fish. The Grand Banks of Newfoundland of Canada are formed when the warm Gulf Stream meets the cold Labrador Current. This region is one of the richest fishing grounds on the earth. Florida Current. The northward flowing current between the Florida Strait and the Cape Hatteras is called the Florida Current. In fact, the Florida Current is said to start on the Yucatan Channel because a major part of the water mass flowing through the strait enters into the Gulf of Mexico. The same water joins the Florida Current after some distance. After its exit from the Florida Strait, Florida Current and the Antilles Current join together. Though this joint current is known as the Florida Current up to Cape of Hatteras. Though many theories have been advanced regarding the origin of the Florida current, yet the difference between the water levels in the Gulf of Mexico and the Atlantic coast is regarded as the main cause of the origin of the current. Severdrup and Montgomery assume that at Cedar Keys on the western coast of Florida, the average sea level is 19 centimeters high than at the St. Augustine of Florida on the east coast. However, in the opinion of the Dietrich, the Florida current is only direct continuation of the current through the Yucatan Channel, and that the waters of the Gulf of Mexico are only to a small extent drawn into the Straits of Florida. According to Montgomery, the velocity through the Florida Strait should be 193 centimeters per second, which is somewhat higher than the average velocity at the center of the current. According to the measurements and computations made by WUST, the average transport of water through the Straits of Florida, it's 26 million meter cube per second. However, there is an annual variation in the transport of the water. It is to be noted that the water level on the right side of this current is about 45 centimeters higher than that of the left side due to the presence of high density water on the left. On the right hand side of this current, the water density is relatively lower. After emerging from the Florida Strait, this current flows very swiftly along the continental slope. To the left of this current, the coastal waters are more or less calm, but the transition from the shallow and the calm waters to the main current is rather abrupt, so that there is a distinct tiny line formed by the border of the current. Pillsbury of the United States Coast and Geodetic Survey made measurements of the temperature, salinity and other characteristics of the Florida current in the years 1885 to 1889 from the survey vessel Blake. On the basis of the observations, the surface temperature, this current was found to be 23.8 degrees Celsius and a salinity 36 parts per thousand. The surface temperature of this current was nowhere found to be less than 6.5 degrees Celsius up to the Blake Plateau situated at 33 degree north latitude. The depth of the current was found to be nearly 800 meters. However, further from the Blake Plateau, there is a sudden increase in the depth and the volume of this current. This increase is probably due to the mixing of the water of the southwestern part of the Sagasu Sea, whose average surface temperature is much less than 8 degrees Celsius. Gulfstream. The part of the Gulfstream system between the meeting place of the Florida and the Antilles Current and the east of the Grand Banks is known as the Gulfstream. It follows the continental slope between the Florida Strait and the Cape Hatteras and then continues in a narrow band towards the east. The Gulf Stream appears like a river in the ocean. It transports huge quantity of water, that is about 55 into 10 to the power of 6 meter cube per second. The width of the main current is about 50 kilometers. According to Stormwell, the Gulf Stream is a narrow band of high velocity water which forms the boundary between two entirely different water masses. Because of the presence of this current, the warm water in the Sagasu Sea is not allowed to flow over the cool and the dense coastal water. There is a great difference between the surface temperature of this current and that of the marginal seas of the continent. For example, the temperature recorded on the southern portion of the Gulf Stream is about 20 degrees Celsius during the winter, whereas the temperature in the coastal waters is only 14 degrees Celsius. A sea traveller named Lescarbot observed that in a vertical cross section, the Gulf Stream can be divided into three distinct layers. The surface layer, which is few meters thick and is marked by the seasonal variation of the temperature, and below the surface layer, which is another layer in which there is rapid decrease of the temperature with increasing depth. This is known as the main thermocline. And a third one, which is very thick layer of the cold water below 1500 meters. Let us remember that the high velocity movement of the water in the Gulf Stream is confined to its surface layers only. Generally, the surface waters of the Gulf Stream are characterized by very rapid movement. On the basis of the measurements made by Eileen, the Gulf Stream flows with a velocity of 120 to 140 centimeter per second. According to Dietrich and Eileen, the total transport of the water amounts to about 75 to 93 million cubic meter per second near the Chesapeake Bay. To the east and the west of the eastern distinctive water masses are present. The influence of the bottom release of the ocean on the path of the motion of the Gulfstream is clearly discernible. Up to 33° north latitude, it flows along the Blake Plateau at about 800 meters in depth. But beyond this, the depth of the ocean varies from 4,000 to 5,000 meters. It is interesting to note that since its movement below the 1500 meters is rather slow, the bottom relief does not affect its position and its influence is negligible. The limits of the Gulfstream are determined by the characteristics of its surface waters like the color change and the lines of the Sargassum seaweed. However, the inner edge or the western boundary of the current is defined by the pressure gradient between the warm and the saline water to the southeast and a fresh and the cold water to the northwest. The warm core of the Gulfstream has been defined as the part of the stream in which water is warmer than at the same depth to the east. Usually, it is at 300 to 400 meters. At the left side of the warm core, there is sudden changes in the surface temperature, color of the water and other features. Now, let's dwell into some of the important currents of the South Atlantic Ocean. South Atlantic Ocean flows in a similar pattern as the North Atlantic Ocean, but in counterclockwise direction. The phenomena of the middle gyre or the Sagasu Sea is not so distinctive in the mid-South Atlantic. Brazilian current, which is warm in nature, it is formed by a split in the South Equatorial Current at the Cape São Roque in the northeast Brazil, and hence it is a warm current. It travels southward along the coast of Brazil under the influence of the westerlies and the rotation of the earth. It propels eastwards to merge with the west wind drift as the South Atlantic Ocean. South Atlantic Current and the Bangua Current, which are cold in nature. On traversing westwards, the current is diverted northwards by the landmass of Africa. It is called the Bangua Current, flowing along the west coast of Africa in the northward direction. Bangua Current brings the cold polar waters from the west wind drift into the tropical latitudes. The Bangua Current surges equatorwards in the northwesterly direction to merge with the South Equatorial Current and thus completing the anti-clockwise circulation of the South Atlantic Ocean. The Atlantic Circumpolar Current or the west wind drift, which is cold in nature. This is a dominant circulation in the Southern Ocean. It flows from the west to east in a clockwise direction. Around the Antarctic, the current is circumpolar due to the lack of any landmass connecting Antarctica. The Antarctic convergence, where the cold waters of the Antarctic meet with the warm waters of the subantarctic, is the region of upwelling of the nutrients. These form excellent regions for the growth of phytoplanktons with associated copepods and krill and resultant food chains supporting fish, whales, seals, penguins, albatrosses and a wealth of other species. Fakan Current, which is again cold in nature. A small branch of the west wind drift flows between the coast of Argentina and the Falkland Islands, is called the Fakan Current. This is cold current due to the polar waters of the west wind drift. In cold regions such as the North Atlantic Ocean, oceanic water loses heat to the atmosphere and becomes cold and dense. When the ocean water freezes, forming the sea ice, salt is left behind, causing surrounding sea water to become saltier and denser. Dense, cold, salty water sinks to the ocean bottom. Surface water flows in to replace the sinking water, which in turn becomes cold and salty enough to sink. This starts the global conveyor belt, a connected system of deep and surface currents that circulate around the globe on a 1,000-year time span. This global set of the ocean currents is a critical part of the Earth's climatic system as well as the ocean, nutrient and carbon dioxide cycles.